Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to Solving Radical Equations. I find that with solving radical equations, it helps students to really have an example of step-by-steps that they should do. So that's what we're going to focus on. So step one is always going to be isolate a radical. If you have more than one radical in your problem, you just need to isolate one of them. If you can get rid of the number in front of a radical, that's great. But if you don't want to divide, that's fine as well, as long as you get that radical term isolated. Okay. 2, you are going to use the index to help you identify the power that you're going to utilize. And what you're going to do is you're going to raise both sides to the power. And that will help you cancel that radical. Step 3. And I wrote step 3 so that we could say that it was repeat if you still have radicals. Four, you're going to solve using algebraic skills. By this time, it should be a polynomial function. And then 5, you must do this. I know some people don't like to, but check for extraneous roots. There are some times that, like, if you square both sides, like 5 doesn't equal -5, but 5 squared equals -5 squared, and that's why we are gonna get extraneous roots sometimes. So you're gonna be checking for those extraneous roots every single time. If you have a graphing tool, that can help you. I do want to bring attention to the fact that 3x cubed does equal 27x cubed. However, 3 plus x cubed equals something very different. It will be 27 plus 9x plus, hold on, that's going to be 27x, 9x squared plus x cubed. If you're wondering how I did that, that would be Pascal's triangle. You can go back and watch that video, or you can just multiply it out by hand. But make sure you know whether you have a monomial to a power or a binomial or even a larger polynomial that you're raising the power, because the plus sign or minus sign changes everything. Okay, so let's go ahead and let's find a couple examples so that we can get this started. We are going to start off very simply and work up from there. And I'm going to throw in different variables just so you have to see different variables. It really doesn't make the math any different. So our first example is going to be the square root of y minus 8 plus 5 equals 7. And I'm actually going to side by side do one slightly different, just to show why we're talking about what we're talking. So I did switch the 5 and 7 for the one in pink. So the index is 2, but before I can worry about that, I must first isolate that square root. So in the purple one, we're going to subtract that 5. Okay, now everything is in one group because it's grouped as a single group by parentheses underneath the radical on the left, and we only have one group on the right. So we will square both sides. When I square root and I square, they cancel out. I'm left with y minus 8. And 2 to the second power is 4. So I'll add 8 to the other side and y equals 12. And then we're going to go ahead and double check that. Does 12 minus 8 square rooted plus 5 equals 7? 12 minus 8 is 4. Square root of 4 is 2. 2 plus 5 is 7. Yes, it worked. So what's going to go on over here? We'll subtract the 7. Square both sides. Y equals 12 again. Okay, so now we're going to check. Is it 5? Well, the square root of 12 minus 8, that'd be the square root of 4. The square root of 4 is 2. 2 plus 7 is 9, not 5. Extraneous. And because it's extraneous and we had no other options, this has no solution. And the reason for that is this is a positive square root. So when you take a positive number and you add 7, you're going to get something bigger than 5. We were saying, hey, the square root, this positive square root, needed to equal a negative 2. That wasn't ever going to work. So this is an example of once it was squared, the two equations matched. But prior to squaring, they did not, which is why we got the solution in the one on the left and we failed to get a solution in the one on the right. So this is why we check our answers. In this example here that we see a radical isolated on the left and a radical isolated on the right, and they're both a square root. So is it isolated? Absolutely. I just said get a radical isolated. This time they both happen to be isolated, so that's great for us. So we're just going to go ahead and we're going to raise both sides to the square power because that's the index. So to get rid of a square root, you do the square. And if you ever noticed on your calculator, the square root and the x squared button are on the same key. One's just raised and the other one you have to use your second or shift key for. So when I square this monomial, I get the quantity 5w plus 3. When I square this monomial, I get the quantity 4w plus 3. The great thing here is that there's no exponents, so we can use this like we did in junior high. And we'll go ahead and subtract 4w from both sides. Subtract 3 from both sides, and we find out w equals 0. So now I'm going to check it. What is 5 times 0 plus 3? This side comes out to be the square root of 3. And if I use the other side, 4 times 0 plus 3, it also comes out to be the square root of 3. So they match, so that's good for us. So since there are variables on both sides, I just substituted it into the left, substituted it into the right, and I made sure that they were equal. And that checked out really well. Okay, so here we have a radical and a constant on the left and a variable on the right. So the first step is always to isolate that radical. So I'm going to do that by subtracting 4 to the other side. And then I'm going to use that inverse operation of squaring both sides because it is a square root. Now remember, do not pull a math meme. Save the puppies. If you've heard some of my other videos, you've heard me talk about that meme. You can Google it if you want. On this side, it's a monomial. Everything's in one group. So the square and the square root cancel out, leaving you with just p plus 16. On this right side, however, p minus 4 is being multiplied by p minus 4. It's being squared, which means you must FOIL that out. When you do, you're going to get p squared minus 8p plus 16. If you need to, stop the video, pause it, and double check that by doing your actual FOIL work. Now it's quadratic. And to solve quadratics, we usually want them to equal 0 so that we can either do factoring or the quad formula. So that's what we're going to do here. We're going to subtract everything to the p squared side. 16 minus 16 cancels out, so we're left with that. And what I notice is we have a GCF here. So I'm going to solve by factoring. So P is going to either equal 0 or P is going to equal 9. And if you don't understand why that is, you can go back and watch the video on solving quadratics by factoring. But now I need to check them in the original. So I'm going to check 0. 0 plus 16 plus 4 equals 0. So notice I put in the same p-value in both spots. So the square root of 16 plus 4 is 4 plus 4. That's 8. 8 is not 0. Okay, so 0 is extraneous. We're kicking it out. So now I'm going to test 9. 9 plus 16 plus 4, is it 9? Square root of 25 plus 4, that would be 5 plus 4, that is 9. 9 does indeed equal 9. So my only solution for this problem is P equals 9. Again, the other one happens to be extraneous. Let's try another one like that. Okay, this time I have my variable x. I only have one radical, so I'm going to subtract the 5 to the other side. And then I'm going to square both sides. So on the right, that's all one group. So when I square it, the square cancels out. Here it's a binomial, so when I square it, I must FOIL. And again, we squared both sides. Quadratic, so 0 equals x squared minus 15x plus 50. That factors to x minus 10 and x minus 5. So therefore I'm getting answers of 10 or 5. Again, I like solving by factoring when I can, just better than the quad formula because I can do it in hand. So let's see. The square root of 10 minus 1 plus 5, that would be 9. So square root of 9 is 3. 3 plus 5 is 8. Does it equal 10 minus 2? Yes. That one worked. Okay. Let's check 5. 5 minus 1 plus 5. Does it equal 5 minus 2? This would be the square root of 4, which is 2, and 2 plus 5 is 7. No. That one's extraneous. X equals 10 is my only answer. So you might ask yourself, is that always the case? Does this always happen like that? Well, let's try one more. Okay, the square root of x plus 2 equals x plus 2. So again, I'm going to square both sides. Shorthanding now, since we've done a few of these. Make it equal 0. Factor. I'm getting -2 or -1. Okay, so is -2 plus 2 equal to, so is the square root of 0 equal to 0? Yes, absolutely. Let's try the -1. Is the square root of 1 equal to 1? That's also yes. So this one happened to have two answers. That is allowable. It can happen. One answer can happen, no answer can happen. So we need to make sure that we're ready for any of those situations. Here's our next example. Go ahead and pause the video if you want and see if you can get there ahead of me. First thing I'm going to do is I'm going to square both sides. It's quadratic. I'm going to make it equal 0. And then I'm going to factor. I always find that students make the most mistakes with a 5 for the linear coefficient and a 6 for the constant. This one's going to be r plus 2 and r plus 3. So r is either going to equal -2 or r is going to equal -3. Now I noticed something right off. If r is -2, this side will be -6. If r is -3, this side will be -7. But this side over here is positive. Will a positive ever equal a negative? No, and you can finish testing them. It's just something I noticed because I've been doing math for a long time. They're both extraneous. There is no solution. And if you need to, you can graph them and you will find out that because this one is linear being in its location versus this one being a one-wing function, you'll just find out they never intersect. But, you know, utilize Desmos if you want, graph both of them separately, find where they cross. And you will see that definitely you're going to be getting your line and your one-wing function. And you'll be able to tell that they're not crossing. All right, our next example, now we have two radicals. So that's where that step 3 is going to come in, that repeat. I always isolate my more complicated radical first. So since this has more stuff in it, I'm going to isolate that one first. And I could have wrote -1 plus the square root of k. I just like to start with a positive number when I can. So we're isolating a radical. We're going to square both sides. Again, when we square the left side, that is that monomial. The square and the square root completely cancel each other because everything's being squared, everything has the radical. That's why it cancels out. Over here on the right, you're going to need to FOIL this out, and this time I'm going to go ahead and go back to my grid work so you can see. So this will be the square root of k squared, so that'll just be k. This will be minus the square root of k, minus 1 square root of k, right? This will be minus 1 square root of k, and this will be plus 1. So when I combine like terms, I get k minus 2 square roots of k plus 1. Okay, now this is when we need to isolate that again. So I'm going to subtract k from both sides, and I'm going to subtract 1 from both sides. Okay, here's where you have two options. What I would prefer you did, personally, is to go ahead and divide both sides by -2. And make this 5 equals root k. However, not always will this number divide nicely by that number, and you might have to deal with fractions. So you may not want to deal with fractions. So your second option is to go ahead right here and square both sides versus here squaring both sides. So over here we're going to get -10 times -10, which is positive 100. Here we're going to get -2 square roots of k times -2 square roots of k. So we're going to get 4k. You have to square both parts of that monomial. It's a monomial because it's a multiply problem, not an add-subtract problem. Remember, this here, k minus 9, that's a binomial because there's a minus sign separating. So here we would divide both sides by 4 and get 25 equals k. Here we're also going to get 25 equals k. So if you can divide by the coefficient, it makes your life a little bit simpler. If you cannot, because you can't stand the fractions that you're going to get, just make sure you're using your exponent rules very carefully. Now we still need to check this. Okay. When I substitute 25 in there, that'll give me the square root of 16, which is 4, minus square root of 25, so it'd be minus 5, is 4 minus 5, -1. Absolutely. We only got one answer and it happened to work, so our answer is 25. So again, because there were two different radical signs, we had to square twice. All right, let's try another one of those. I'll give you x this time instead of weird letters. 2x minus 5, 1 minus, oh, hey. Again, we have two square root signs. In this case is the most complicated one by itself. Well, they're both binomials. This does have a number under it, so probably the most complicated one is by itself. So we're going to go ahead and square both sides. Shorthand what we're doing there. Now on the left, that's going to be super easy. We're just going to get 2x minus 5. On the right, I'm going to grid that one out again. Sorry about that, not focusing very well today. My camera is not in a happy mood apparently. Okay, 1 times 1 is 1. 1 times the negative 1x square root of 3, right? 1 times negative. Now here we have negative times a negative, so that's a positive. And we're going to have the square root of x minus 3 times itself. So that's going to be squared. So that cancels that. We're just left with x minus 3. So we're going to have 1 minus 2 of the square root x minus 3's plus x minus 3. So we can combine like terms here. And I'll write that over here in brown. So we're going to have negative 2 square roots of x minus 3 plus x and then minus 2. Okay, and I like the color coding because I can tell that the pencil was my side work versus the brown is my actual problem work. And again, I just did this grid to help you visualize foiling out that 1 minus the square root of x minus 3. You might be a rock star and not need that. Okay, I'm going to subtract x from both sides. I'm going to add 2 to both sides. And this is what I was talking about, that it may not divide nicely. So I'm going to go ahead and show this one both again, once where it has the division version and once where it doesn't. Okay, so I just divided the right side, the negative 2 from the right over to the left in pink. That's what I've done there. Okay, so if I square both sides, I'm going to get x minus 3 squared equals negative 2 root x minus 3 squared. Now this is a binomial because of the minus, and we're going to get x squared minus 6x plus 9. Here this is a monomial, so each part of the monomial gets squared, so that will give me 4x minus 3. Okay, we're going to put a pin in that for a second. Here, if I square both sides, I'm going to get x squared minus 6x plus 9 over 4 equals x minus 3. Well, now I have a fraction. Can't I just multiply that 4 to the other side? Absolutely. And now see how we're at the same spot either way. So I don't care whether you make it fractions or not, you're going to get to the same point. I'm going to continue from this one here on the left, and I'm going to go back to writing in pen. So I'll distribute my 4. It's quadratic, we need it to equal 0. X squared minus 10x plus 21, that actually factors. We get x minus 7 times x minus 3. So x is either 7 or 3. Okay, so we need to test 7. Does 7 work? Well, 14 minus 5 is the square root of 9. The square root of 9 is 3. 7 minus 3 is 4. The square root of 4 is 2. 1 minus 2 is negative 1. Nope, 7 got kicked out. marked it out down here. Okay, now I'm going to test 3. 2 times 3 is 6. 6 minus 5 is 1. So we get 1 when we do the square root. Okay, we're testing 3. 3 minus 3 is 0. The square is 0, 0. 1 minus 0 is 1. Hey, 3 worked. And again, if you need to check those on a calculator or Desmos or whatever, please do so. I just talked about it mentally, but definitely go ahead, and if your computation skills are not as much as you'd like them to be, just go ahead and use that technology to help you. Here you'll see I deviated, and now I've written a cube root. The problem doesn't work any differently. We've isolated the radical. We need to use an inverse power to cancel this out. Just instead of squaring both sides, because we changed our index, we're going to change the power. To get rid of a third root, we need a third power. That's going to give us x minus 1 equals 8. So x equals 9. And the third root of 9 minus 1 is the third root of 8 is 2. So it does work. So what happens when you have something like this? Which do you do? Well, we've isolated a radical, use inverse operations, cube both sides, right? That would give us the square root of x cubed equals x. Now to get rid of the square root, we can square both sides, which would give us x cubed equals x squared. Or instead of in 2 steps, I could have rewritten this as x to the 1/2 equals x to the 1/3, right? Using those inverse powers. I'm going to give them a common denominator, 3/6 and 2/6. So really the inverse power is to get rid of dividing by 6. I'll raise both sides to the 6th power. And when you multiply 3/6 times 6, you just get 3. And when you multiply 2/6 by 6, you just get 2. So now it's a cubic equation. Now we set it equal to 0. And we're going to factor. I have a GCF of x. That factors more. So I see I'm getting 0, -1, or +1. And I need to check all 3 of those. Does the square root of x equal the third root of x? So when I check 0, the square root of 0 is 0. The third root of 0 is 0. It worked. When I check -1, the square root of -1 is undefined. The cube root of -1 is -1. That did not check. And when I check +1, the square root is 1, and the cube root is also 1. So -1 is extraneous. The other 2 were verified. So it is okay to have a square root on one side and a third root on the other side. We just have to make sure that we are looking into using basically a common index or a common denominator to help us out. Here we see 2 different equations, one with a 3/2 power and one with a 2/3 power. And you might say, hey, these do not have radicals in them. You're right, they don't actually have the radicals written, but this is really the square root of x squared minus 3x minus 6 to the 3rd power minus 14 equals -6. And this one's really x minus 2 squared cube root plus 5 equals 30. And if it helps your brain to write them like I have them there in pencil, go ahead and do that. It might help you solve them easier. I am going to choose to solve them differently so that I don't have to do so much work by hand. I want to do stuff in 1 step instead of 2 steps, and I'll expand on that in a moment. Okay, so from here, Again, I want to isolate this part. So I'm going to add the 14 to the other side. Okay, so now that it's this polynomial, quadratic, right, to the 3/2 power, I need to use the reciprocal power. So since this is 3/2, I'm going to do 2/3. And whatever I do to the left, I have to do to the right. So when you have double powers like this, you multiply. And 3/2 times 2/3 is 1. So that would leave me with x squared minus 3x minus 6 to the first power. And if you type 8 to the 2/3 into a calculator, you're going to get 4. So now I'm going to subtract 4, so because it's quadratic, x minus 5, x plus 2. So x equals 5 or negative 2. Okay, let's check 5. 5 squared minus 3 times 5 minus 6. That's 25 minus 15 is 10, minus 6 is 4. And we've taken that to the 3/2 power. So 4 cubed is 64, square rooted is 8. And 8 minus 14 is negative 6. 5 worked. Okay? Or you could just type into a calculator. Negative 2 squared minus 3 times negative 2 minus 6. That would be 4. 4 to the 3/2 power is 8. And 8 minus 14 is negative 6. They both worked. Okay, so we're getting 2 answers there. So I'm going to come over here, and you might really be wondering right now why I'm doing a second one, especially when one is a 3/2 power and one's a 2/3 power. They seem super alike, right? So I'm going to write x minus 2 to the 2/3 power equals 25. To get rid of the 2/3 power, I'm going to need the 3/2 power. In double powers, remember you're going to multiply. So that's going to give us x minus 2 equals plus or minus 125. Oh, hold on, back up the truck. Why did I suddenly write plus or minus here when I didn't write plus or minus here? And it has to do with this piece here. Because this is a squared, we're eventually doing the 3/2 power, which is doing the cube, and then doing the square root. And anytime you do a square root, you must have the plus or minus. Whereas here we got rid of the 3rd power. The top number was 3, so we're doing a cube root. With a cube root, it didn't matter. So, because the power that we did to both sides had an even denominator, since we had an even denominator on both sides, we had to remember the plus or minus. And that's going to be the #1 mistake I see on these, is knowing when to use a plus or minus and when not. You can always verify if you have a graphing utensil. You can verify it that way. If you don't, then you might just have to double check. Obviously, whenever you get to your final answer, checking for extraneous roots will help that pop out. So x is going to be positive 2 plus or minus 125. 2 plus 125 is 127, and 2 minus 125 is negative 123. And I will go ahead and tell you that they both work. So 127 minus 2 is 125. 125 to the 2/3 power is 25, plus 5 is 30. Negative 123 minus 2 is negative 125, but when you square it, it becomes positive, so that's why we're getting positive 25 plus 5 is 30. So really utilize inverse powers to help you isolate things, but also make sure you double check all your answers for extraneous roots, and pay attention to when you need to do plus minus versus when you don't. Thanks for learning with me here on Math with Michelle. If this helped, give it a like, and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.